Okay, welcome everyone to this deep dive. We've got a really interesting set of sources today, all looking at something called Agnos.
That's right. It used to be called Fidata, I think. But yeah, Agnos. The sources cover it from a few angles, overviews, some GitHub tech details, even a performance comparison.
Right, so our goal here is to, unpack what Agnos actually is, what its core capabilities are supposed to be, and maybe figure out what makes it potentially different in this, well, frankly, crowded space of AI agent builders.
Definitely. It's moving so fast.
So let's start basic. Based on these sources, what is Agnos?
Okay, so fundamentally, the docs describe Agnos as an open source framework. It's for building what they call agentic systems, basically a toolkit for developers.
Agentic systems?
Yeah.
Okay, that sounds like more than just chatbots. What does agentic mean in this context, according to the sources?
It really comes down to capabilities. These aren't just passive things. The sources say these agents are built to have memory, so they remember past conversations or actions.
Mm-hmm.
They can use knowledge bases, not just their training data. They can use tools, think external APIs, search engines, that kind of thing. And crucially, they're designed for reasoning, making decisions.
Got it. So memory, knowledge, tools, reasoning, and it helps build domain-specific ones and connects to any LLM.
Exactly. That model agnostic part seems pretty key. Yeah. You're not locked into one provider. And they talk about building these systems across 5 levels of complexity.
Oh, levels. How does that work?
Well, you might start simple, maybe an agent that just uses a tool.
Uh-huh.
Then you can add knowledge, memory, better reasoning, all the way up to complex teams of agents working together on workflows.
Okay, so scaling complexity. That makes sense. What else stands out from the sources about Agnos, maybe philosophy or key features?
A really big theme is performance and efficiency. It's designed to be lightweight.
Lightweight, yeah.
And besides being model agnostic, they list support for over 23 providers. It's also built to be natively multimodal.
Natively multimodal, so handling text, images, audio, video even, all baked in.
Yeah, that's the idea, not cobbled together afterwards. And then there's this concept of agent teams, which seems central.
Right. You mentioned teams. How does that work?
It's about building groups of agents that can actually collaborate. Each might have its own role, its own tools, but they share information to tackle bigger problems.
Interesting.
And the framework apparently bundles in things like a UI, monitoring tools, built-in ways to handle memory and storage, and even pre-built tools for searching with DuckDuckGo or Google or getting stock data using Finance.
Okay, practical tools included.
Yeah, and structured outputs too. So the agent doesn't just give you text, it can give you formatted data.
Uh-huh.
And they mention pre-built fast API routes to serve these agents easily.
All right. Now, let's get into something the sources seem pretty excited about, this performance comparison, specifically Agnos versus LangGraph. What's the story there?
Yeah, this was definitely highlighted in one of the sources. They ran benchmarks, and the claims are, well, pretty striking. They say Agnos agents instantiate basically, get ready to run in about 2 microseconds.
2 microseconds, incredibly fast.
That's the claim. And they compare that to LangGraph, which they measured at around 20 milliseconds for instantiation in their tests.
Okay, wait. Microseconds versus milliseconds, that's what, 10,000 times faster?
Roughly, yeah. That's the factor they're claiming. About 10,000 times faster just to get an agent started.
Wow. Okay, that's a huge difference. What about memory? Does it mention memory?
It does, same comparison source. They claim an Agnos agent uses about 3.75 KB of memory on average.
KB, okay, kilobytes basically.
Right. Compared to LangGraph, which they pegged at around 137 KB in the same tests. So roughly 50 times less memory per agent.
So way faster startup and a tiny memory footprint. Why is this such a big deal according to the sources? Why obsess over microseconds and key?
Well, the argument is all about scale and real-world use. If you're building something complex, maybe with lots of concurrent users or a workflow involving, say, dozens or hundreds of agents, then those small numbers per agent suddenly become massive overheads. That speed and low memory use, they argue, is what makes it feasible to build large, scalable, cost-effective systems that actually work in production, not just in a demo.
So it's really aimed at bridging that gap between cool AI experiments, and, production grade systems.
That seems to be the core message, yeah. Though, to be fair, the sources also note that speed isn't everything. Accuracy, reliability, those are obviously critical too, and benchmarks for those matter just as much.
Right? Performance is only one piece of the puzzle. So, practically speaking, what kinds of things did the sources show people building with Agnos?
A few examples. Things like generating reports by pulling data from documents or APIs. Answering questions by querying databases, or agents performing tasks like sending emails automatically.
Okay.
And they bring up that agent team idea again, like an example using a web agent to find info online and a finance agent with financial tools working together to give market insights, each using its specific skills.
Okay, so summing this up based on what we've read, Agnos is positioning itself as this very lean, very fast framework aimed at making it easier to build these potentially complex multi-agent AI systems that can actually scale up.
That sums it up pretty well. The key takeaways from the sources seem to be that efficiency, the flexibility with models and data types, and this built-in support for agent collaboration.
Right? So thinking about this for you, the listener, when you see frameworks like Agnos putting such a massive emphasis on performance, claiming things like 10,000x faster start times, it makes you wonder, doesn't it? How fast could this push us from today's often experimental AI agents towards, well, truly robust multi-agent systems handling really complex, maybe even critical tasks in production? Could that future be closer than we think? Something to definitely keep an eye on.